Problem number 3 on the specific heat worksheet is going to be done much in the same manner as problem number 2 with a few little tricks. One thing I want you to notice is that these solutions, both the HCl and the sodium hydroxide, these are pretty dilute solutions. We've got 0.5 molar and 1.2 molar. Since they're very dilute solutions, they are mostly water, and that is a little assumption that we are going to make when we work with this. So we're going to use Q equals MC delta T to find our kilojoules, and then we'll deal with our moles. So Q equals MC delta T. Now, our mass in this one, I told you to take the mass of whatever's changing temperature. Well, both of these are changing temperature. So what we're going to do is we're going to add the volumes up together. So you've got 55 milliliters of HCl and 65 milliliters of NaOH. Those two added together give you that 120 milliliters of solution. Since these are very dilute solutions, they're going to have about the same density as water. So 120 milliliters is 120 grams. So that's one of the assumptions you have to make to be successful with these problems. So 120 grams times, again, since these are very dilute solutions, we're going to use the specific heat of water, since that's mostly what they are, being so dilute. All right, and then our change in temperature here is 4.8 degrees C. All right, when we calculate that, we're going to end up with 2410 with 3 sig figs joules. Again, if it's over 1,000, go ahead and convert it to kilojoules. So 2.41 kilojoules. All right, now we're going to get the moles. Here we have to know a little bit of chemistry, and in these, since both of them are reacting, you really have to go with the limiting reactant. Most of these problems are done per mole of water. So you're mixing two solutions together, it's usually kilojoules per mole of water. So we'll write our equation, NaOH plus HCl. It's a double replacement reaction. This one's going to form a salt. This time it happens to be table salt and water. So we want to figure out how many moles of this. So in order to do that, we need to know the moles of this, of our NaOH and HCl. So 0.5 molar, and we have 0.055 liters. Again, that's the 55 milliliters up here, expressed as liters since we're dealing with molarity. Multiply those two together and you always get moles. So 0.0275 moles of, oops, I did that wrong. Let's see if I can get rid of that. And multiply these two together and you get, I just have it for the wrong substance. Let's try that again. That was where I went wrong. All right. So 0.5 molar and 0.055 liters. Now that's 0.0275 moles. Now the NaOH, I have 65 milliliters, which is going to be 0.065 liters. And I have 1.20 molar. Multiply molarity times liters, and you always get moles. So that's 0.078 moles. Now, because this is a 1-to-1 mole ratio with everything in here, we can see that HCl is going to be our limiting reactant. If you go to moles of water, you're going to find that 0.0275 is going to be the least number. So that's how many moles of water we are going to form. And I'll just show you this one here. In 1 mole of HCl, you're going to form 1 mole of water. And so the amount of moles will be 0.0275 moles of water. And then kilojoules per mole, you are just going to divide those two. So kilojoules per mole. And so we take our kilojoules, 2.41 kilojoules divided by 0.0275 moles. And we end up with 87.6 kilojoules per mole. One last step, is this reaction exothermic or endothermic? Well, it released heat because the temperature went up, And so this is an exothermic reaction, and we just put a negative sign on it because that means exothermic. We use that sign to notate direction.